33. A hyperbola has vertices at 2, -5, and 2, 3. The eccentricity is 2.236. What's the value of b to the nearest integer? So in this problem, we got to work with the hyperbola, which we could look at the formula chart and see that the hyperbola is given down here in conic sections as one of these two forms, depending on if this is horizontal because the x is positive, this one would be vertical because the y is positive. And so we have to work from that and determine what b is. Eccentricity comes from the formula E equals c over a. So in this case, 2.236 will equal c over our a value. So how do we solve this problem? Well, first, I'm going to just graph the points they've given me and determine if this is horizontal or vertical. So we go right 2 units, down 5 units, to plot a point. This is a vertice, which means it'll be a part of the hyperbola, like the centerpiece of a parabola, if you will, or the maximum or minimum value of one of the two parabolas. And the other point is right 2 up 3 units. And so this is going to be a vertical hyperbola because the vertices are stacked vertically on one another. So it would look like this. Now, this value, if they're vertices, are the a values. So the center is in the middle of these two. This one's 5 down, this one's 3 up. That means a total of 8 units. So 4 units from either one of them. So 4 units down would take me here, or 4 units up would take me here. This is the center. The center is at 2, -1. So as I go to write the equation, since it's vertical, I'm going to use the vertical equation here. And I would know that it would be y, to make it go down 1, I'd have to put +1 in parentheses squared over a squared minus, to go right 2, I would say x minus 2 squared over our b squared equals 1. Now, what values do I know? Well, I can tell my a value here. My a value is that distance, which is 4, and you can check it by going this way. It's 4. So a equals 4. If that's the case, then a squared is 16. Now, what's the connection between c and a? And it's this, that c squared equals a squared minus b squared. And so at this stage, we know that a is now 4. And so I can figure out what c is just by multiplying both sides by 4. So if I multiply by both sides by 4, we'll get c. So I'd come over here and say 4 times 2.236. I have 8.944 for my c. 8.944. So now if I square that, and put this in the calculator, well, I'll just write it out like this. This will make it easier. 8.944 squared will equal 4 squared, because that was our a, minus b squared. Now, when I square this, let's see what we get. 8.944 squared. And I need to subtract from that 4 squared. And that means that is my b value. And when I take the square root of that, I found out that it's basically 8. So 7.9999695, that's basically 8. So b, it says to the nearest integer, we're going to say that b here is roughly 8. Now, I know you would think, what about the negative? Well, the negative's taken care of there, which means the negative always gets flipped to positive whenever you plug in this value right there. So that's why I'm just treating it like that. And so the value of b here is 8. Besides that, if you think about it, b tells us which way to move. You don't ever move just a negative direction both ways. You would move 8 this way and 8 this way. So that's going to be our correct answer here. The value is 8. Now we could check this by, if I put this in here, and I'm going to change 8 squared is the same thing as 64. I'm going to check it real quick by going to the calculator. Oops. Menu, graph entry, equation, hyperbola, and we said it's a vertical one. So we first had y minus 1. No. Let's look back at it. Yeah, it's y plus 1 So I need to have a negative here to make this become a plus, because it starts off as a minus, so it's y minus 1 there. And then it's x minus 2. Now underneath the y, we had 16, which means it was 4 squared. And over here, we said our b is 8. So let's check this. If I press enter, I get this value. And I want to check and make sure some things in the right location. So I go to Analyze Graph, Analyze Conics, and I'm going to first check my vertices. Were they supposed to be 2, 3, and 2, -5? 2, -5, 2, 3, that looks good. And the last thing we need to check is the eccentricity. So Analyze Graph, Analyze Conic, and I click eccentricity, and I do get 2.236, 2.236. So it worked. So if all that seemed like to be too much work for you, what I would suggest is that you would open up, figure out where the center is, you get this part of the equation, and you get this a value by counting from the vertices, and then just plugging in numbers until you got an eccentricity that matched. Now that I've already put eccentricity in the graph, what do I mean by plug in numbers? I could just press tab here and change my equation, and what would happen every time, if I press tab, is I could change this 8, and my eccentricity would automatically update. Let's try 7, and you'd see that this value is no longer good. And so you could just go through and keep trying numbers until you found one that would work, and 8 would be your number.